This is Mr. Herman, and our topic today is graphing inequalities. So, we're going to start graphing inequalities, and before we even need to get to graphing them themselves, they're real similar to graphing a line. Okay? Graphing an inequality is like graphing a line. The only difference is we have to consider two things. The first thing is the line dashed or solid, and we'll talk about that. And the second one is, where do you shade? Okay, so that might not necessarily be something that we know yet, but we'll cover that. So the first one here is the line dashed or solid. That has to deal with if we have an equal to or a not equal to. So if we are just graphing a line, we have an equation here, just an equal sign. That will be a solid line. If we have y is greater than or equal to 3x minus 1, since we have an equal to here, that is a solid line. 2y is less than or equal to x plus 3. That is a solid line. Okay, now we have 2x plus y is greater than 1. That is a dashed line. X is less than or equal to y plus 3. That is a dashed line too. Okay, so if we can kind of see a pattern here, when we have an equality component, the line is going to be solid. When we have no equalities, just less than or greater than, the line is dashed. Okay, if we remember to when we graphed inequalities with one variable, if we had an open circle, we had less than or greater than. If we had a closed circle, it was equal to, greater than, less than or equal to, or greater than or equal to. So this is kind of the same idea here. So now we're going to talk about shading. So since inequality solutions are greater than or less than, their solutions might not be on the line. So we will pick a point. We'll pick a point not on the line and plug it into the inequality. If it's true, we will shade that side. If it's false, we will shade the other side. So let's go ahead and do an example to see what that's going to look like. So we have an inequality graphed here. It's a solid line because we are greater than or equal to. So I'm going to look at here and I'd say this point 0, 0 is not on my line. So I'm going to plug 0, 0 into my equation. So my y value is 0. My x value is 0. And the minus 1 stays there. Let's go and simplify. So 0 is greater than or equal to 3 times 0 is 0 minus 1. Okay, so 0 is greater than or equal to negative 1. That is correct. So what we're going to do now is we are going to shade on this side of the line. What that means is that any point on this side of our line will be a solution for this inequality. Now, we're going to do a couple problems together to practice. And so we've got y is less than or equal to 2x plus 1. So let's go ahead and look for the y-intercept. Okay, so the y-intercept is plus 1. And then we'll do the slope. So I need to go up 2 over 1, up 2 over 1. And then this is going to be a solid line because we have that equal to part here. So I'll go ahead and connect those dots. Okay. So there's our line. Now, in order to show our solutions, because that's y is less than or equal to 2x plus 1, we have to check a point. I always like to check the point 0, 0 if I can. In this case, we can because 0, 0 is not on the line. So here's 0, comma, 0. So let's plug into the inequality. So my y value is 0. Less than or equal to 2. My x value is 0 plus 1. Okay, so let's see. 2 times 0 is 0 plus 1. 0 is less than or equal to 1. Okay, that is true. So I need to shade on this side of my inequality. So that means that everything on the right side of my line could be a solution to this inequality. Let's go and do one more. Okay, so we have x is less than or equal to y plus 3. So let's do a little bit of maneuvering because this is not in slope-intercept form. So I'm going to get y by itself. So I'm going to do minus 3, minus 3. Now, since x and negative 3 are not like terms, I just have to put them like this. Okay, now we can graph it. So the y-intercept here is negative 3. 1, 2, 3. Our slope is, if I don't see a number in front of there, that's 1. So there's our slope. So I'm going to go up 1 over 1, up 1 over 1. Now, since we have a less than symbol, there's no equal to here, we have to make a dashed line. Okay, so we've not made a dashed line yet, so let's make a dashed line. Okay, so there we go. That just means that the solution cannot be on the line. Now, just to shake things up a bit, we're going to use a point other than 0, 0 this time. I'm going to use the point, let's use the point 1, comma 2. Okay, we're going to check this point right here. 1, comma 2. All right, so my x value is 1 here. And my y value is 2. All right, so 1 times 1 is 1, minus 3 is less than 2. So 1 minus 3 is negative 2, is less than 2. That is correct. Okay, so that means that we're going to shade on this side of the line. So that means that any solution, any point on the left side of our dashed line, the top left side of our dashed line, would be a correct solution.